Hi, good evening. Today I'm gonna take a video of how to solve the exercise 6 concerning the microwave energy. It says that the dielectric constant of BF at 23 degrees Celsius and 2450 megahertz is 28 and the loss tangent is 0.2. The density is 1004 kilograms per meter cube and the specific heat is 3250 joules per kilogram Kelvin. Potato at 23 degrees Celsius and 2450 megahertz has a desirable constant of 38 and a loss tangent of 0.3. The density is 10 kilogram per meter cube and the specific heat is 3720 joules per kilogram Kelvin. Now part A says that a microwave oven has a rated output of 600 watt. When 0.25 kg of potatoes were placed inside the oven, the temperature rise after 1 minute of heating was 38.5 degrees Celsius. When 60 grams of potatoes was heated in the oven, a temperature rise of 40 degrees Celsius was observed in the oven. After 20 seconds, calculate the average power output of the oven and the mass of potatoes that must be present such that power output of the oven is limiting the rate of power absorption rather than the capacity of the material to absorb the microwave energy. Now, as I told you before, when you are reading the question, try to write down the given on the paper, and this is actually what I did. So I almost wrote everything down the paper: dielectric constant of the beef, the loss tangent, the beef density, the potato, what is happening, the rate of the output of the microwave oven. I even wrote down the question that is needed for me to solve, because for this I can understand more what is the question, how is this dealing, what is needed out from me. And you can see that I have something that I have a cross, I have some X's, I have some ticks. This means that when I am solving the question, I do even repeat it and I do even try different things in order to reach the answer. So it is really okay and very normal when you are trying to solve to not fetch out the answer immediately. You repeating several times, trying several times, taking with you an hour in order to solve an exercise for the first time is something that is normal. And again, trying several times to solve the exercise would be better in order to facilitate for you understanding the question, knowing how to behave and how to reach the final answer. The more you practice, the more you reach. Let's keep this in our mind. And now starting to solve the exercise. In A, you should assume that 0.25 kilogram mass of product is sufficient to make microwave power availability the rate limiting factor for the microwave absorption. And for this, we calculated the power using the equation mCp delta T. The mass is 0.25 kilogram. The Cp is provided by the given, which is 3720 joules per kilogram Kelvin. The delta T, which is the heating that it rises 38.5 degrees Celsius after 1 minute. So I'm gonna multiply it by 60 seconds, but in the denominator down because it's per 60 seconds in order to have it in seconds, not in minutes. And the answer would be 4828.25 watt. Now that I've got this power and this power that resembles the power output of the oven, when I have a small amount of material that is heated, I am going to calculate its power as well. I mean the power of 60 grams of potatoes now. The power of 60 grams of potatoes, not of 250 grams of potatoes, is equal to 0.06 multiplied by the specific heat of potatoes, 3720, and then multiplied by the temperature difference. We have a rise of 40 degrees Celsius, so 40 plus 273 in order to convert it to Kelvin, multiplied by 1/20 because this rise of 40 degrees Celsius happened over the average of 20 seconds. So in order to know in 1 second how much we've got the power, this is how we calculate it actually. And the answer would be 34,000 or 3,493.08 watt. Now, if I look at both answers that are provided over here, I can see that although I have reduced the number or the mass of the material of the potatoes inside the microwave, I got a decrease in the resultant power, not an increase. However, we had in our mind that once we decrease the mass material inside the microwave, what would happen to the power that is absorbed? It should increase per a relative unit. And therefore, this provides us the assumption that this is actually the limiting rate of heating. So already, when we've got 0.06 grams, we have reached the limiting power of heating. Okay, so no matter what is the mass, no matter how much we reduced even more the mass, we have reached the limiting absorbing power of heating. Now we still have to calculate what is the mass that must be present when we've got the power output of the oven is equal to the limiting absorption power of heating. And in other words, this would be the mass where the actual material that is heated, which is potatoes in our case, is dependent only upon or the power output of the microwave. For this, although I thought of trying this equation first, but no, I went to this one, which is Q over V, the absorption limiting power, or the absorption power, which is equal to 3,493.08, the one I just calculated over here for the 0.06 kilograms of potatoes, divided by the volume. Now, how do I calculate the volume? It is the mass over the density. So 0.06 divided by 1010. Okay? The final answer of this QV would be 58.8 watt per centimeter cube. And this is the limiting power absorption by the material. Now, because we have to put in our mind that the limiting power absorption by the material is per unit volume, Q over V, okay? So over here we have calculated the power, and here we have calculated the limiting power absorption by the material, Q over V. Considering that if the power output of the oven is equal to the power of absorption, in order to know what would be the limiting mass, okay, and we are trying also to put in our mind, is it from 0.06 that we have a mass that is independent of that of the power oven? There must be a certain mass actually, if it is 0.06 or maybe even a little bit higher. I mean, maybe at 0.07, this is the mass of the potatoes that is independent of the power out oven. Or maybe at 0.075, this is the mass of the potatoes that is independent of the power output of the oven. So maybe 0.06 is not the limiting mass criteria that we should start from. That's what we have to assume, and that's why we're gonna put the Q over V, which is the limiting absorption by that of the potatoes that we have figured over here, which is the 3,493.08, equal to the power output of the oven over the volume of the potatoes that we need actually to calculate. Now the power output of the oven would be 4,828.25 watt. Continuing this, we have the volume over here. It would be the mass over the density, okay? And then we just substitute, rearrange the equation, and we've got the mass 0.08 kilograms. This means that starting from 0.08 kilograms, we've got the potatoes having the maximum limiting power of absorption. And in other words, or the other way around, any mass above 0.08 kilograms would be dependent on the power output of the oven, not on the limiting power of absorption. Okay, and by this 0.08 kilograms would resemble the mass of the potatoes that would absorb and depend upon the power output of the microwave energy. Now if we want to calculate the Part B, if potatoes and beef are heated simultaneously, what would be the relative rate of heating? If I want to calculate the relative rate of heating, I'm gonna use the equation 6.48, and I guess this is in slide 51. I'm gonna calculate the derivation of T1 over T2, and this would be equal to the density of material 2 over the density of material 1 multiplied by the relative dielectric loss multiplied by the specific heat of the material 2 over the density of material 1 multiplied by the dielectric loss of material 2 and multiplied by the specific heat of material 1. I've got to assume, so you could either put let 1, the subscript of 1 be beef and let 2 be potatoes, or vice versa. In my case, I have determined that 1 refers to beef and 2 refers to potato. And I've substituted the density of the potato is 1010. The dielectric loss of the potato could be calculated knowing that the relative dielectric loss, epsilon double prime, is equal to dielectric constant times tangent delta. And the dielectric constant of the potatoes, we have already written it in the given. It is 28 times 0.2. and then multiplied by the specific heat. We have assumed that it is for the beef. So this is the dielectric constant for the beef. Let me look again because now yes. Now the given is on the other page round. So it is 28 times 0.2 corresponding for that of the beef. And the CP2 for the potatoes, it is 3,720. And the density 1 for the beef, 1004, multiplied by the dielectric constant for that of the potatoes, 38, times tangent delta of the potatoes, 0.3, times the specific heat of the beef, 3,250, and we're gonna have 0.565. So this is actually the relative rate of heating between the beef to that of the potatoes, and because it is 0.565 less than 1, we could assume that the beef will be heating slower than that of the potatoes, and this is actually very logical. And I guess you can answer why, because the molecules that are found inside the beef, they are much more compounded than that of the potatoes, which facilitates the heating and the speed up and the rearrangement of the molecules in alignment to that of the electromagnetic fields once they are exposed. Because we have said that we have two methods of the alignment of the heating and the rearrangement of the particles corresponding to the exposed electromagnetic waves, ones by the dipole rotation and the other ones by the ions that are going to arrange themselves according to the electricity that is provided. By this, we have finished this exercise. In case you've got any questions, please do not hesitate to refer to me and to answer. And again, I do emphasize that you try to practice as much as possible, as many exercises as possible, and then you will feel yourself much ready to solve any exercise in front of you. Best of luck!